now. So, past community news, the elections are coming up, and if you haven't heard, if you want to be eligible to vote in the next past board elections, you have to go into your past profile and update it by June 1st. Otherwise, you will not get a ballot and you will not be able to vote. So please do that. And if you are not registered yet, then by all means go ahead and register. Then, of course, you won't have to update it again. Past Summit is coming very, very close, just around the corner. So if you haven't attended a Past Summit before, I highly recommend it. It's an awesome, awesome experience. And if you are interested, there's an introductory price until July 12 of $17.95. And as part of this group, you also get a $150 discount by using the discount code that appears on your screen. So I hope to see all of you there. So this is just one virtual chapter out of a couple of dozen virtual chapters. So whatever your interest is, whatever place in the world you are, there are virtual chapters in different languages on different topics with different speakers, but they all share the passion for learning, and you're going to get the best speakers out there and get the best learning, and it's all 100% for free thanks to the work of the volunteers. If you want to see a couple of examples of virtual chapter meetings coming up, some of them I've already attended, so actually the only one is the last one, the data architecture in 3 days. More than welcome to join. Troubleshooting SQL Server with extended events. There's also, PASS also offers full days of free training, which are called SQL Saturdays. As you can see on the left, if you're in North America or the international ones, go to SQLSaturday.com, register. Again, full day of training, best speakers in the world, in your local region, 100% free. So by all means, go and join. And if you would like, of course, PASS cannot exist without volunteers. As I said, we're a nonprofit organization, and we're here for the community. So if you want to give your share to the community, please look for volunteering opportunities at volunteer.sqlpass.org. And that's about it. So without further ado, let me give the wheel to Stefan Barron of Microsoft, who is going to teach you today about DocumentDB. Stefan, are you ready? Can you share your screen?
I am. Let me know when you can see my screen.
I can see your screen. By the way, people, if you have questions, you have the questions tab in your panel, and just type in the question and I will inform Stefan of the questions. So Stefan, go ahead. Let's begin.
Absolutely. Thank you very much. So I am a program manager in the Azure DocumentDB team, and clearly today we're going to talk about Azure DocumentDB. So I'm going to assume that there's not a ton of familiarity with, say, NoSQL solutions and with document databases in particular. So the first few slides will sort of be a recap of, hey, what is a document database in the first place? So most folks have probably heard of NoSQL. There are various types of NoSQL solutions out there, such as key value stores, graph stores, and one-column stores. And then one of the more popular types of NoSQL systems are document databases. So if you're familiar with MongoDB or RavenDB or CouchDB or Couchbase, or if you've heard of those solutions, these are NoSQL document stores. Most document stores will deal in JSON documents. There are a couple, such as MarkLogic, for example, that deal in XML documents. They are, for the most part, built for simplicity and scale and for various types of performance. DocumentDB in particular is built for handling massive amounts of ingestion, so massive writes while still serving very predictable and low latency reads. When we talk about scale for NoSQL solutions, the general idea is that you scale out as opposed to scaling up. So as opposed to adding a bunch of memory or processor or buying new hardware, what you do is you scale out by adding commodity hardware. And as we'll see with DocumentDB, we take a scale-out approach as well. And finally, they are non-relational in the sense that the server does not enforce schema. Now, I've heard folks describe NoSQL solutions as schema-free. I don't really like that term because clearly your data must have some schema, or else your application or applications couldn't reason over that data. The difference between a relational store and a non-relational store like a document database, again, is just that the server doesn't define or enforce any schema in a document database. So you are free to insert documents that have different sizes, different shapes, and so forth. And we'll see a little bit of that as we go through the deck. So document databases are great for these types of documents. You see this is a bunch of well-formed JSON that has arrays, various properties, sub-documents, sub-objects, and so forth. So it's hierarchical data, typically denormalized in a document database. And you're looking at documents that, again, have structure, but you can imagine that there could be different types of documents stored within this database, stored within a particular collection, and they don't have to look alike. They could vary very slightly, or they could vary dramatically from one another. Not so great for these types of documents, and the difference between this document and the previous one is, well, this one only has a couple of fields. You can see that that data field really has a bunch of, you can imagine that's a bunch of free-form text. A key value store might be really good for this type of document. Even maybe a relational store, if all of your documents or all of your records here have two properties and that's it, then a document database probably isn't going to buy you very much. And just to be very clear, definitely not for these types of documents. So Microsoft and others have great solutions for storing Word docs and PDFs and so forth. Document databases, again, primarily deal with JSON documents, so JavaScript object notation, or in some cases XML. DocumentDB deals strictly in JSON documents. So before we get into DocumentDB itself, I thought it would be useful just to briefly cover some use cases. So as we go through some of the capabilities of DocumentDB and we talk about some of the characteristics of document databases, hopefully starting out with some use cases will make some of the features and scenarios that we talk about later a little more relatable. So we have lots of production customers. We launched our public preview back in August of last year, so we've been around for about 9 months. And on April 8th, we went to general availability. So it is a GA production, SLA guaranteed Azure service at this point in time. We have a number of production customers, both internal and external. This slide mainly talks about some external customers and great use cases for document databases in general and DocumentDB specifically are catalog data. And why is a document database a good solution for catalog data? Well, you can imagine that products in a catalog have different shapes and in some cases very dramatic different shapes, and you don't know over time what other types of products you might wind up selling. So having a database that gives you some schema flexibility where you're free to insert documents of different shapes over time allows you to do that without having to modify fixed schema, alter tables, and so forth. So you can imagine a catalog where I start out selling bicycles and wheels, which in and of themselves look different, but then later on I start selling GPS units and T-shirts and candy bars, and I don't have to worry about getting my schema right at the very beginning of my application, nor do I have to worry too much about modifying my schema over time, or again, storing products in my catalog that have dramatically different shapes from one another. Events and logging, we find a lot of IoT scenarios that are looking at or using DocumentDB. And this is not just IoT systems like HVAC systems and temperature units and so forth, but even we are working with several vehicle manufacturers who want to store vehicle telemetry information. And again, you can imagine that the sizes, the shapes of that data coming in could differ dramatically. So just between car models, the types of information being submitted by Model A versus Model B versus Model C could be very different. And you may want to add new telemetry information over time, and again, not worry about A, getting your schema right up front, or B, modifying your schema over time. Similarly, with temperature sensors and HVAC systems, you could imagine a company that is monitoring temperature devices within a building, and some of those temperature devices may have been installed 5 years ago, some of them may have been installed a year ago, and even the same types of temperature devices owned by the same company could differ in the types of data that they're providing. So sensors that were installed 3 years ago might just provide a sensor ID and the actual temperature, and they submit that data every 30 seconds or 1 minute, whereas newer temperature sensors that are installed by the company supply an ID, the actual temperature, and perhaps the humidity. So again, not having to worry about defining schema up front. And then another interesting use case we have is teams inside of Windows Phone today and within Microsoft are using DocumentDB to store their restore state for devices. And again, you can imagine lots of different types of devices, and then even within the same device, say a Lumia 1020, the apps that I have installed means that I'm going to have different restore settings than the apps that potentially Ami has installed, because he has a completely different set of apps, or even just slight differences in the apps mean that the shape of the restore settings are going to actually look dramatically different from one another. And if the Windows Phone team there wants to support some new device that comes out, well, they may not even know ahead of time what the shape of those settings documents might look like for the restore settings. So one other thing I want to be very clear on is I'm not here to convince folks to take all of your SQL and relational data and put it in DocumentDB, because that is not a great idea. One of the points of this talk and of DocumentDB and document stores in general is because relational stores have been around for so long, you can get in the habit of treating them like a hammer and making everything else look like a nail. And relational stores are great, obviously, for tons of scenarios. But there are scenarios where document stores or key value stores or blob stores or dedicated search engines like a Lucene or a Solar or Azure Search, which is a search as a service product, make more sense than a relational store. So when you think about these other types of databases, these other types of data storage solutions, such as document stores and search and key value and blob, it's simply a matter of having a good number of tools in your tool belt and knowing when to choose one over the other. And again, not looking at every data storage problem as a nail and SQL Server or another relational store as being a hammer that fits every situation. You can certainly shoehorn just about every data storage problem into a relational store. You just may not be getting the best performance possible, the best flexibility possible. There may be alternate solutions out there. And again, similarly, document stores are not great solutions for certain types of applications and certain types of data. If you have data that is very highly relational, if you have data that must be operated on like an OLTP store, document stores are not the right solution for that type of data or for that type of scenario. So now we'll get into Azure DocumentDB. It is available, obviously, in Azure, and it today is only available in Azure, so there is no on-premises version of DocumentDB. So if you want to use DocDB, then you must use it in the context of Azure. It was built from the ground up as a fully managed, multi-tenant, resource-governed service. So we get asked from time to time, hey, I noticed that Microsoft is far more embracing of open source technologies, and they seem to be a lot friendlier towards partners nowadays. Why did you guys go and build some document store from the ground up, as opposed to just building on top of an existing document store solution? So we looked at existing document store solutions, and in fact, you can run Mongo and Raven, and you can run Cassandra, which is not a doc store, but is a NoSQL column store. You can run all those things in Azure. So we love open source. We want to make as many choices available as possible within Azure. But when we looked at those solutions, none of them were really built from the ground up to be a true multi-tenant cloud-based solution. And it's a very different proposition when you're trying to build a multi-tenant system, because you need to make sure that you solve these resource governance and noisy neighbor problems. And it turns out that, again, the other solutions we looked at just didn't do that. And we had a need for this type of solution within Microsoft. DocumentDB actually started out as a project for the Office teams for OneNote. And then we decided that, hey, this would make a great public service. So we should go ahead and just, harden this service and offer it as a public service. So what DocumentDB gives you is, again, not schema-free, but schema flexibility. We have a very deep commitment to JSON, so that is the type of document you give us. We don't do anything to that document. I mean, we add a couple of system properties, but we don't store it as anything other than JSON. So you give us JSON, and you get back JSON. Similarly, we've made a very deep commitment to JavaScript as our application programming language for server-side scripts such as stored procedures, triggers, and user-defined functions that we'll talk about a little bit later. One of the unique features to DocumentDB, at least I think it's still unique, is that we support multi-document transactions. So you could imagine if you were storing player ranking documents for a game system, and every time two players faced off against one another, very simplistically, their ranks just swapped. So if I was player rank number 3 and I went against player rank number 5 and I lost the match, then I would go down to 5 and that other player would go to 3. Well, because each user has their own document within the system, you certainly, just like a bank transaction, would want to make sure that either both of them get updated or none of them get updated in the case of a failure. So we support that through the use of server-side JavaScript in the form of stored procedures. Our automatic indexing is another differentiator. So we'll get into this in a little more depth later on in the talk. But by default, we will automatically index every property of every JSON document you give us. And then we give you control over the indexing policy as well. So if that policy, the default policy, doesn't work for you, then you have lots of knobs at your disposal to tune the indexing behavior of DocumentDB. And again, we'll talk about those. And then it's scalable, where you don't have to manage VMs, operating systems, software patches. We do weekly, usually more than once a week, deployments to production, where you're getting new features, new performance benefits, bug fixes in the case where we have bugs, and you don't have to worry about any of that. So again, no applying of service packs, no patching of operating systems, no applying CUs. It's just a fully managed service, and when you need more storage or throughput, you simply go to the Azure Portal, or programmatically you provision more collections, and that gives you more storage and more throughput, and we'll talk about that as we go on as well. So I'll start out with brief coverage of the DocumentDB resource model, so that things subsequent in the talk will make a little bit more sense. So the first thing you do is you provision a DocumentDB account. And if you're familiar with Azure Storage, for example, it's similar to a storage account. So you provision an account that will give you back a set of keys, so a couple primary keys, or a couple master keys, primary and secondary, that give you full access to the account, as well as a couple read-only keys, again, primary and secondary, that allow you read-only access to the account. And then if you need more granular permissions, we have this notion of users and permissions that I won't talk a ton about today, but very briefly in the next slide. Underneath a database account, so once you've provisioned a DocDB account, you can create one or more databases. Databases are simply a boundary for our notion of users and permissions. So you can create users in DocumentDB, and you can assign them permissions at various resource levels. So you could assign them permissions at a database level, at a collection level, even at a document level if you want to. Underneath a database, you create one or more collections. Now, collections are where your documents actually get stored. And a collection was probably an unfortunate choice of terms for us, and it's too late to change it. But if you're familiar with Mongo, collections are not DocumentDB collections are not like Mongo collections. Mongo collections are quasi-virtual, where our collections are actually a storage, a data partition of 10 gigs. If you need 20 gigs, 30 gigs, 40 gigs worth of storage, then you simply provision 2, 3, or 4 collections, respectively. So each collection will give you 10 gigs of storage. That includes data as well as the index storage, and we'll talk a little bit about how much storage index consumes a little bit later. And collections also give you a set amount of throughput. So if you're familiar with Azure SQL DB, they have this concept of DTUs. We have a similar concept that we call request units. So we have 3 types of collections today. They all give you 10 gigs of storage, and they differ in the amount of throughput or the number of request units they will give you, going from 250 request units on the low end up to 2,500 request units per second on the high end. And don't confuse request units with requests. Every operation against DocDB will incur some request charge. That could be 1 request unit, it could be 200 request units, it could be 1,000 request units. Because you can imagine that things like writing a 1K document, for example, is a less expensive operation than writing a 256K document. And similarly, doing a query against a collection that says select star from this collection, where there's 1 million documents in that collection, is a far more expensive query than select this individual document from this collection by its individually unique ID. So every operation in DocDB will incur a request charge. Every operation will return that request charge to you so that you can optimize queries over time, optimize your write patterns and read patterns, and we'll talk a little bit about what happens when you exceed your number of request units for a particular 1-second time frame, how you can handle that and how the server behaves. Collections are the billable resource in DocumentDB. So you could have 8 databases, and that's fine, but you can't store any data until you provision a collection. So each collection will cost a variable amount of money per month, depending on its performance level. So today, an S1 collection that gives you 250 request units per second is $25 a month. An S3 is $100 a month, and an S2, right in the middle with 1,000 request units per second, is $50 a month. They are billed hourly, and you can dynamically scale them. So perhaps you use a set of S1 collections for the whole month, except for every Friday is very busy, so you scale those collections up for 24 hours every Friday, and then scale them back down to an S1. You'll only be billed the S2 amount or the S3 amount for the number of hours that collection has been in S2 or an S3. And it is the highest performance level within an hour. So if you have at 9:01 a.m., you scale an S1 collection to an S2, and at 9:30 you scale it to an S3, and at 9:50 you scale it back to an S1, that 1 hour charge will be for an S3 because that was the highest performance level that collection was entitled to during that hour. The other thing to note is collections are not tables. And what I mean by that is, as we discussed earlier, and as I'll probably say a few more times throughout the talk, you can store documents that have different shapes and different sizes and look, again, slightly dissimilar to one another or dramatically different from one another. You can store those all in the same collection. So if you had an application that had user documents, user blog post documents, and user profile documents, you can store all those in one collection. You don't have to create 3 different collections to store each of those 3 types of documents. I think we talked about this. So again, we take in JSON, we give you back JSON, the server doesn't enforce any schema, and by default, our indexing policy will index all properties of every JSON document you give us. All of any DocumentDB resource is addressable by a logical URI. So all of our APIs are REST-based. We provide a number of SDKs to make programming against us easier than just going directly against our REST APIs. But if there's not an SDK that you like, for example, maybe you like programming in Go, since everything is available over REST APIs, you could certainly write your own SDK in Go or just use that and call our REST APIs directly. All of the data is partitioned for scale out and replicated multiple times for high availability. And all of the interactions with DocumentDB are over secure channels. So the server does enforce HTTPS or an SSL secure channel for a proprietary protocol we have that's called direct TCP connectivity. But again, everything is encrypted over the wire. So now that I've walked through the resource model, let me show you what this would look like in the Azure Portal. So hopefully everyone can see my browser now. This is, so the other thing I should mention is if you're familiar with Azure, there is the old Azure Portal, the classic, the V1 original Azure Portal, which is I think manage.windowsazure.com. And then there's a new portal the preview portal, which is available at portal.azure.com, and lots of new services in Azure are only available in the new portal. And DocumentDB is one of those services that is only available in the new portal. So if you go to the V1 Azure portal, the manage.windowsazure.com, you are not going to find DocumentDB, nor would you find services like Azure Search. So within the Azure portal, you can make a new DocDB account by clicking New, and we're in the Data and Storage category. So if you click Data and Storage, you'll usually find us right here on that first blade. And provisioning an account is very simple. You simply tell us what's the host name that I want. We're going to append .documents.azure.com to this. So if I wanted something called SB Demo, we'll do a name check to make sure it's available. This one happens to be available. If I provisioned this account, then my endpoint, my DocumentDB account, would be available at sbdemo.documents.azure.com. And then you choose a location. Today we are available in 6 locations. You can read them. So 2 regions in the US, 2 in Asia, and 2 in Europe. We have plans to expand into additional Azure regions throughout the rest of this year. So if there's a region that you're interested in which is not available today, chances are it would be available later this year as we go about expanding into additional regions. It usually takes about 10 minutes to provision an account. Once you have it provisioned, then everything is, hunky-dory. Go ahead, create databases, create collections, as fast as you want, essentially. So I'm not going to wait 10 minutes to provision a new account. I have a couple existing accounts here. So here is one of them. And just to illustrate the resource model, as well as cover a few things about the management experience, when you first launch into an account, you're going to be presented with the account blade itself. So this is going to give you metrics at the account level, which means all the metrics of any database, any collection underneath this account are going to be aggregated up at this level. So this is my account. From here, I can get my keys. I mentioned the master keys and read-only keys that are available. So that would be on this blade here. And then I have information on the databases that are available, some links over to samples and documentation. And if I go into one of these databases, the blade itself is going to be very similar. But now the monitoring, so the metrics here, are going to be for all of the collections within this database. And I have a list of collections. And then if I drilled into a particular collection, now I'm going to get metrics just about that particular collection. So that would be both the request information as well as the storage. So if you look at the storage of the account, this account has 233 megs of storage today. This database, this MyDB database, has 232.6 of that, and then this collection, this company's collection that I'm on, has 100 megs. So you can see again, as you drill in, your metric and storage information is going to get a little more granular. We also have some tools to both view and create documents within the account. So if I pull one of these up here, and click on these, you'll just see, again, this is just JSON data. I mentioned earlier that we add a few properties to each document. So if I click properties here, I'll get the system properties. This RID is what we call a resource identifier. It's unique within the system for that document. Every document has an _TS property, which stands for timestamp, which is a last modified property. We convert it to a friendly form here, but it's actually stored as a epoch value within the document. A self-link is, again, sort of a fully qualified link to that document. And then eTag, if you're familiar with eTags, these are a way to handle concurrent operations over the internet. So it's an HTTP standard. And you can imagine if I had 2 different clients that had access to this DocumentDB collection, and I grabbed this document, and another client grabbed this document, and I went and wrote my changes to this document back, the E tag would be updated, and the next client that went and, again, grabbed the document before I updated it, if they went to go update the document, the server would detect that there was an E tag conflict and return them a conflict response, and that's how you can make sure that people aren't updating documents that have been updated from the time they retrieved those documents. We also have a query explorer that we'll get into in a later demo that allows you to run SQL-like queries against the documents in your DocumentDB collections. So I'll switch back to the presentation. Ami, is this a good time? Are there any questions so far, or should we continue?
Oh, sorry, I was muted. Can you hear me now?
Yes, absolutely.
So there is a question here. Let me just, it looks really small. Is the first question by Ashish is DocumentDB a good choice for data warehouse solutions? And also, is it available as a standalone product?
Okay, so I'll take the second one because that's an easy one. Today, no, it is only available as an Azure service. So there's two things that we've heard from folks, and this is in order based on the number of times we've heard the feedback. The first one is people would like a local emulator type experience so that they can do local development without having to have a DocumentDB account dedicated to development, or they can do offline development. That's certainly something we're looking at. No timelines to disclose. And then the second question, is it a good choice for data warehousing solutions? It kind of depends on the scenario, and I know that's not necessarily a satisfactory answer, but we have really good integration with Hadoop and with Azure HD Insight, and there are a couple slides toward the end of the talk on that. So if those two slides don't answer your question, then let's follow up on that question at the end of the talk.
Okay. Yeah, so now people starting asking questions, which is great. Arthur asks, what is the maximum document size?
So the max doc size today is 512K, and that is minified. So you give us a JSON document, and we minify it before storing it within the system. So that gives you essentially 512 some odd thousand characters per document. We're looking at increasing that. Just to give you an idea, when we first launched public preview, our max doc size was 16K. I'm glad everyone's muted so I can't hear you laughing, because we knew that was a pretty ridiculous limit as well. So very shortly thereafter, we raised it to 128K. A couple months after that, we raised it to 256. And then just about 2 months before GA, we raised it again to 512. So we're looking at potentially increasing it again. Again, no timetable and no actual number of what that eventual size might be. But 512K, we have found suffices for most folks, although we do have some use cases that we've heard from folks that are valid use cases and reasonable use cases that do demand a larger doc size, say around a meg. So we are looking at what we should do in that area.
Okay, great. You want to take a couple of more questions, or you
Sure.
want to continue? Okay.
No, absolutely.
So John asks, from an administration perspective, how could ops manage it? Well, do you have like PowerShell commandlets, or what is the managing interface?
Yeah, so there is the portal today, obviously, and then for management plane operations, there are REST APIs exposed, and then you can do them programmatically through any of the SDKs. In terms of management, if you're talking about configuring indexing policy or scaling, and scaling really is adding more collections or modifying the performance level of a collection, so going from an S1 to an S2 or an S3 down to an S1, for example. Those can all be done programmatically. They can also be done through Azure PowerShell, and we are going to expand our PowerShell footprint as well. So today, if you were going to use Azure PowerShell to do lots of those management plane operations, they would just be done through the generic set Azure resource commandlets. We will at some point have first-class DocDB PowerShell commandlets for that, but you can use the Azure PowerShell commandlets, our SDKs, or our REST APIs directly for that.
Okay, great, which actually leads us to the next question by Ashish. What type of indexes are available?
Great, so today we have hash and range, and we are working on a couple additional types. So one of them, I don't know if we've publicly announced it. I think we might have updated our user voice page. So we have a page where people can request features and vote for features. So one of the next most requested index types was geospatial. So that is one that we are working on. We haven't announced a date, but I think we have announced that we are working on it. And in fact, we are working on it. So geospatial will be the next one. Another request we've had from folks, and we haven't started this work, is for full text indexes. Today we have a great integration story with Azure Search, which is a fantastic search as a service solution that I believe uses Lucene under the covers and has support for all the advanced full text features you would want, like boosting and faceting and stemming. I think they support 30 some odd languages. So we have really good integration with Azure Search, where Azure Search is a first-class DocDB indexer, so you can point Azure Search at a set of DocumentDB collections and use that for full text search needs. We are looking into the possibility of providing a full text type index going forward as well, but nothing committed in that area.
Awesome, thank you. Another question by Tyler, is the ETAG conflict resolution built in, or does the application need to handle the checks?
So what will happen is if you violate ETAG concurrency, then the server will return you a standard HTTP 409 response, which is a conflict. And then the application would have to go and decide what to do, right? Would it go ahead and refetch the document, what have you? But it would be up to the application to handle it, but the server itself will reject the update with the 409 response, with a conflict response.
Okay, and last question for now from Alon. What if I insert into a partition more than 10 gig? How can I scale, open another DB?
Great, great question. So we're going to cover this a little bit later, but now we'll talk about it for a second so we can breeze through those next slides. Once you get close to your limit, you have a number of options. Well, really your only option is to provision more collections, generally within the same database, although they don't have to be within the same database. But we recently released an update to our .NET SDK that has sharding support. So if you're familiar with SQL Azure DB and their Elastic Scale sharding support, we have something very similar. So we support hash-based sharding, consistent hash-based sharding, range-based sharding, spillover sharding with our SDK update. So that's the 1.1 version of the SDK. I believe we released it 3 weeks ago. So we have a couple built-in sharding strategies for you, like I mentioned, hash and range. And if you have your own unique sharding strategy, you can extend the SDK and implement that. But again, by default, we have support for hash and range-based sharding out of the box with the newest version of our SDK. So you would go ahead and simply partition your data across multiple collections. And you would do that for a couple of reasons. Number one is for the reason you pointed out. If you need to store more than 10 gigs of data, which lots of folks probably do. And the other reason you would choose multiple collections would be if you need more throughput than a single collection can provide. So if you had, let's just say you had 5 gigs worth of data, but that data was very, very frequently accessed and very, very frequently updated, and it turns out that 2,500 request units per second just wasn't enough for you. You could provision 2 collections, 3 collections, 4 collections, shard your data across those collections, and now in the 4 collection case, for example, S3 collections, you would have 10,000 request units at your disposal. So those are the 2 reasons to scale out, more storage or more throughput.
Awesome. So that's it for now. I think we can continue, and we'll probably have a little more questions near the end.
Great. So once you have a DocumentDB account and 1 or more databases and collections, you can imagine this view on the right here. There's these 4 documents in this collection, and you can see they all look a little bit different from one another. One of them has this last use property, another one has a first use property. Another pattern that we see people using is aggregate documents. So instead of having to perform aggregate operations on the fly, they may maintain a set of aggregate documents in a collection. And whenever a new document gets added, for example, maybe they use a DocDB trigger to go and update that aggregate document. And in this case, maybe the aggregate document has 2 properties, which is the count of docs in the collection and the last modified date of the latest doc or something. So every time a doc gets updated or added to a collection, maybe that aggregate doc gets updated. So we have, I mentioned, a number of SDKs to interact with DocDB. And then we also have a SQL-like grammar. And I say SQL-like because clearly we don't support every keyword that's out there and every piece of functionality that's in ANSI SQL. But when we had this choice to make early on, should we go and invent some new query language, like some databases have a tendency to do, or should we go and adopt something very familiar to folks? And we went the latter route and chose to adopt a SQL-like query language for a couple reasons. The primary reason was familiarity, right, and getting people up and running very quickly. So selects in DocumentDB work just like selects would against a normal relational store like SQL Server. We have a few peculiarities like the way joins work in DocDB and so forth, and I'll cover a few of those. But the SQL grammar today, one thing to note is it's read-only. So we don't support updates through the SQL grammar today. So we don't support things like the update keyword or the set keyword. So today it is all about reading data, the query language. Clearly, we will expand the query language over time, not only for new functionality in terms of read operations, but also to include update functionality in that query grammar. And then I mentioned server-side scripts, and I'll show you what a couple of those look like later. Today we support stored procedures, triggers, and user-defined functions that are shipped to the server, compiled on the server, and executed within the database engine itself. So I've mentioned the SDKs a few times. I haven't mentioned the exact SDKs we have, so I'll cover that very briefly. We have a .NET SDK. We have a JavaScript SDK, a Node SDK, a Python SDK, and a Java SDK. All of them are open source with the exception of the .NET SDK, which will be open source at some point. There's just a couple of issues we have to work through in terms of legal procedures and so forth. Those are the SDKs we have today. There are some community-developed SDKs. I think I mentioned Go earlier. I believe I saw a Go SDK that was developed by the community. We accept PRs and contributions to our SDKs, so folks have wound up contributing to those SDKs, and we've incorporated some of their changes. The Azure Portal, of course, I showed you, and we'll go back into that portal a little bit later. We also released an open-source tool that we call DocDB Studio. This is what it looks like. I'll walk through this one a little bit later in another demo, but this allows you to perform lots of operations against DocDB accounts, and it's a Windows client-side application. So if you don't want to work in the portal, or if there's something not exposed in the portal, like today we don't expose in the portal the ability to create stored procedures or triggers, you could do that through DocDB Studio if you didn't want to write your own program. So DocDB Studio sometimes will get features before the Azure Portal gets those features, just because it's easier for us to update that tool than it is the portal itself. And then at GA, we released a data migration tool that allows you to import data to DocumentDB from a variety of sources. I'll show you those sources because I believe the next slide is a demo for that tool. And we recently updated that tool as well, and we'll have another update coming out shortly. So I'll switch over to the migration tool. So this is an open source tool. It's available on GitHub. We also make a compiled version available on Microsoft Download Center. So if you don't feel like going to GitHub and compiling the source you're on your own, you can go and download the latest version from Download Center. We released it at GA with support for importing JSON files, CSV files, importing from SQL, from MongoDB export files. And last week, or 2 weeks ago, we released an update that now supports import from Azure Table. The interesting thing, or one of the interesting things about this tool is tabular sources like SQL and CSV, you can actually transform that tabular data into hierarchical data. So in SQL, for example, you'll notice this query that I put in here. Let me just expand the tool so you can see it a little easier. You'll notice that I have done some projections here and projected properties like catalog description as model.description and product model ID as model.id. And then I've told the tool that I have this nesting separator character of a dot. And what that means is when the JSON document is constructed for each of the records that match this query, it's going to create a model property, and underneath that, it's going to create an ID property and a name property and a description property. And if I switch back to the portal, I have an account that I've actually run that import against, and I believe it is in this account. So I'll show you what some of the resulting data would look like. Anyway, yeah, it's this one. So I'll take this time to open up the Query Explorer real quick and just run the default query of select star from C. C is just an alias, so I could call this select star from foo, select star from bar, or select star from the collection name if I wanted. But you can see that we created this model property, and underneath it, those nested properties for ID and name and description. And you can also see that we respected the type information in SQL in as much as we could. So because we support JSON and we strictly adhere to the JSON spec, that has pros and it has cons. The pro is, well, we adhere directly to the JSON spec. Some of the cons are JSON does not have an elaborate type system. So JSON today supports a handful of types such as string, number, bool, object, array, and is defined, right, or null. The type that is notably lacking from first-class JSON support is date time. So what do you do with date times in DocDB? Because we don't support a date time type, since we adhere strictly to the JSON spec, what folks wind up doing usually, and we do this with our underscore TS, our timestamp field, store it as an epoch number. And now you can easily do range queries against it and so forth, and it becomes very easy to work with in epoch format. When you're importing through the tool, we'll give you some advanced options to deal with date times. So you can ask us to persist that as a string, as an epoch, or as both. So if I chose both, what would happen is I would get, let's say that the property for date time here was called model date or something. If I chose both, we would create a property called model date, and underneath that we would create two subproperties, one called epoch and one called, I think, value. So one would hold the string value, the other one would hold the converted epoch value. So I mentioned the other sources we support are CSV and table. For CSV, we'll be releasing an update probably in a couple weeks. Today, if you import from CSV with the tool, everything comes in as string. And why does it come in as string? Well, because obviously CSVs don't define any type information. The update that we'll release in a couple weeks will include support for types in CSVs. And the way it'll work is we'll just try to brute force. So if you have unquoted values in a CSV, so let me start out differently. If they're quoted, they just come in as string. If you have unquoted values, in this order, we'll see, is it, can I convert to a number? If so, store it as a number. Secondly, can I convert to date time? If so, store it as date time. And third, can I convert to a bool? If so, store it as a bool. And if all those brute force operations fail, then just go ahead and store it as a string. So that's one of the improvements we will release with the tool in a couple weeks. So that'll be the third update to the tool in, say, 6 weeks or so, 7 weeks of launch. So this tool we're also looking at rapidly iterating on. And then I mentioned and showed DocDB Studio earlier. So this here's one of my accounts. This is the one I actually just showed you with that query. Here's some stored procedure that happens to be in that account. Here's a user-defined function that happens to be in the account, and so forth. So DocDB Studio will let you do lots of different operations against your DocumentDB account, including adding documents, editing documents, executing stored procedures in a test manner, adding and editing stored procedures, deleting triggers, and so forth. So if you can't do something in the portal and you don't feel like doing it programmatically, chances are you can do it through the DocumentDB Studio. And again, this is available on GitHub. So if you go to GitHub and just do a search for just DocumentDB space Studio, it's pretty easy to find. So I'll go back to the presentation and talk briefly about query. And then I'll show you some examples of query. But I mentioned earlier, probably a couple times already, by default we'll index all properties. You have control over that, which we'll speak about in just a few minutes. The system is optimized to handle massive amounts of writes while still serving very, very predictable and consistent queries in a low latency fashion. We support predicates and projections and array iteration. One thing that we do not support today that is a notable missing feature that is coming very, very shortly is order by. So we will be introducing support for order by, again, very shortly. And actually, if anyone on the call winds up trying out DocDB and you want early access to order by, if you send me an email, and I think this deck will be made available. My email address is right on the first slide of the deck. We can get you early access to the order by support as well before we officially release it. We have our SQL grammar that I showed you briefly and we'll show you a little bit more of very shortly. We also have a link provider in our .NET SDK. And even though it's a read-only dialect today, we do support parameterized SQL. And this is to help guard against information disclosure through SQL injection attacks, for example. So we do have full support for parameterized SQL. It looks just like parameterized SQL support, and you can use that again to guard against SQL injection. So I'll switch back to my DocDB account, and I'm going to go into a different account with some Crunchbase company data to show you some of the language features we have and some of the SQL query behavior. So let me wait for that to come up, and I'll pull up my queries on a different monitor, because if I have to type these in, we're going to be here for a very long time, and I'll probably make a ton of mistakes along the way, fat fingering them. So I'll go into this database here, and I'll just launch my Query Explorer. And once that comes up, I'll go ahead and make sure that I'm in the right collection, which is my companies collection. And I'll start off with a very simple, right, select star from C, just like I did in the previous demo, and I'll get back a bunch of company information. So what we'll return you in the Query Explorer, and again, this gets returned through all the SDKs, through the REST APIs as well, is the request unit charge. So this particular query cost me 250 request units. And if I have an S3 collection, that gives me 2,500 request units per second. If I exceed that quota in a 1 second time frame, the server will return you a 429 response, an HTTP 429, which is a request rate too large, and it will also give you a retry after header, which will say retry after in milliseconds. So it might be retry after 13 milliseconds or 18 milliseconds. The .NET SDK will implicitly retry 3 times on those, and then after that, your application would have to handle any subsequent throttling retries. But the .NET SDK does it automatically for you. The first 3 retries are free, and we will build that support into the other SDKs as well. This will show me the number of results that are showing right here and whether there are more results. And if there are more results, I just hit next page to go get the next set of results. That next page incurs another request unit charge. And then we always give you an activity ID. So if you had some error with a query or you had some issue where something just wasn't working right or you didn't think it was working right, if you ever escalated to Azure support or escalated to us through an MSDN form or something, if you give us that activity ID, we can easily trace what happened on the back end through our telemetry logs. So I'll show you some other queries quickly. So this was just select everything. Okay. And the next query I'll show is if I want to select, say, a particular product. Again, very familiar. So select star from products P, where p.product number equals this string, right? And I run that query, and I get a much lower request charge, number 1, 3.3, and actually there were no documents there that had that product number, so I must have the wrong product number. Oh, I'm in companies here. I'm in the wrong query. So let's go back. And I'll execute a query that will actually work here. I forgot I'm in my Crunchbase data. So that's good, right? No results. Here, what I really want to do is select where the company name is Twitter. So I get back 1 result. It was 24 request units. This is a large collection with lots and lots of documents. And the documents themselves are relatively large, as you can see. So here's, this is 1 document, right? Because there's only 1 entry for Twitter in this collection. You can see it's a pretty big JSON document. Now, if I didn't want that entire document and I just wanted to do a projection here, that's really easy. I can just say I want the name property and then the funding rounds, again, where name is Twitter. And now I just get a smaller JSON document, and here's all the funding rounds. You can see this is an array. So inside the funding rounds array is an object for each funding round that's occurred. The Crunchbase data also has some interesting relationship information. So if I wanted to see all the relationships for Twitter, again, I pull back the name and now just relationships. And I see, oh, Jack Dorsey, right? He was a co-founder. At one point, he was the executive chairman. So what if I then wanted to find all the companies where Jack Dorsey was listed as having a relationship with that company? Well, I can do select c.name. And I will join intra-document. So we support intra-document joins, so joins within a document. And this is really good for iterating over arrays. And you see the relationships property here is an array of relationships. So for every document in this collection, I want you to iterate through the relationships property and find me companies where that relationship property person.firstname is Jack and person.last name is Dorsey. Now this query is going to show a couple things. Number 1 is it shows the use of join to go through arrays and within documents. And number 2, it's going to show how conditions can affect request units and where you may look to optimize certain query patterns. So here I'm doing a query that's that has a single and condition here, right? Where first name is Jack and last name is Dorsey. So I'm going to run that query. I get back 5 companies. So he was involved with Twitter, and he was involved with Ustream and Walt Disney and Square. And you can see my request unit charge is 157, so kind of a high charge. Now I also noticed that this person subfield has a permalink field, which is just a concatenation of the first and last name with a hyphen in the middle, so Jack-Dorsey. So I'll show you the next query, which is going to have the same exact set of results, but the query is slightly different. So what I'm doing is I'm looking for the permalink equals Jack-Dorsey, which means I've eliminated that one and condition. So I'll get back the same set of results, but you can see my query charge was actually reduced to 1/3 the original one. So query charges are a combination of the number of conditions involved, the size of the results coming back. There's a bunch of factors, but one place where you really need some administration, some optimization is in optimizing queries. And because we return that request charge for every single query, for every operation, in fact, you can easily go through and figure out, hey, which queries are good candidates for me to have a second look at, a third look at to optimize and try to get those query charges down. So I'm going to switch back to the deck because we do have a few more slides to go over, and I want to leave at least a couple more minutes for questions. So I mentioned JavaScript. So the way you do multi-document transactions is through stored procedures. We also have support for triggers, and we have support for user-defined functions. You could imagine if I switch back really quickly to my DocumentDB Studio, here is a user-defined function, and it's just simple JavaScript. So what this does is I could use this user-defined function to convert a property that is expressed in grams to pounds, right? So I would simply call this UDF inside my SQL query, and I would get the this property that is expressed in grams. I would convert it and return it to the user in pounds. You can imagine user-defined functions can be used for lots of different things, like calculating tax rates, for doing metric conversions like we're doing here. Lots and lots of different scenarios for user-defined functions. So I'm not going to go through this one. I just showed you the UDF. I also have a stored procedure and a trigger inside of that collection. But I want to talk about indexing for a couple minutes. So I mentioned that we index all properties by default, but you have control over the policy. And we essentially give you 4 knobs to control the policy. The first one is what we call modes. So by default, we synchronously update the index. We call that consistent indexing. On every document write or every document update, we will synchronously update the index to reflect that write, that delete, or that update to the document. We also have a mode called lazy, which is the system will use some percentage of your throughput, essentially, of your request units to allow the index to catch up, right? So it will be updated asynchronously. This is great for bulk ingestion scenarios. So maybe you would set your mode to lazy. You would import a bunch of docs, right? A couple million documents, so you get the maximum write throughput. And then you would go ahead and flip it back to consistent, and the index will catch up. And then for your periodic updates and your periodic writes and deletes, you can leave the index in consistent mode. The policies are automatic and manual. What that means is, by default, it's automatic, which means by default, we index all the documents coming in. If you set it to manual, that means that you tell us when you're writing or updating a document, you give us a special directive that says whether you want to include or exclude the document from the index. So you can set it to manual and just tell us the individual documents that you actually want to index. Then we have support for paths in the JSON documents. So you could imagine if you had some document that described authors, and the document had properties like author last name, author first name, their birth date, where they were born, and then maybe it has some property called metadata that has just a bunch of information in there, and you're never going to query on the metadata property, right? You're just going to query on the author ID, first name, last name, and so forth. You could exclude that metadata property from the index, and what that will do is a couple things. Number one, it will increase your write performance because it's less information we have to index. And number two, it will decrease your index storage costs because, again, that's less information you have to index. Now, on a standard 1K document with about, say, 50 properties, we find that our default indexing policy is about 6 to 8% overhead for the index. So if you stored 9 gigs worth of documents, you would have 600 to 700 megs of index overhead. So we're pretty efficient on indexing storage, but there are other reasons that you might want to exclude particular JSON paths within your documents. And finally, types. I mentioned this earlier. Today we support hash and range, and geospatial is on our short-term roadmap. We talked about performance levels, so I'm not going to go over this, but again, you can dynamically adjust these, and your collections are billed by the hour for the highest performance level that collection was set to within an hour. These are the prices for the performance levels today. Again, you can see all of them give you 10 gigs of storage. They only differ in the amount of throughput that they provide. So collections, again, each allocated 10 gigs of storage. By default, we allow you to provision 100 of them per account. If you need more than 100 collections, you simply call us up or file an Azure support ticket, and we'll go ahead and increase that limit to whatever you need. We have production customers that are running with hundreds of collections, and by hundreds I mean 300, 400, 500 collections today. So essentially, you can think about it as infinite scaling, right? So you just tell us how many collections you need. We'll make sure that your quota is bumped up appropriately. And again, by default, you can provision up to 1 terabyte of storage per database account because we give you a 100 collection limit by default. We talked about partitioning, so this was a recent SDK update where we will help handle lots of the partitioning and sharding across collections for you. I'll skip this demo. I was just going to show you in the portal. You can highlight a particular collection and you can go ahead and scale that collection in the portal. You can also do it programmatically. I mentioned we have great integration with Azure Search for full text search capabilities. We also have a Hadoop connector, so we have really nice integration not only with Hadoop but with Azure HD Insight. And this allows you to use DocumentDB either as a source for HD Insight information, where maybe you want to run aggregations across different DocumentDB collections, because collections today are the boundary for a particular query or a particular stored procedure. So you could use Hadoop HD Insight to run aggregations across DocumentDB collections, databases, even different DocDB accounts. Or you could use it to combine DocDB data with other data sources, like source data from SQL, from files stored.
Stefan?
Yes.
We're going to need to wrap up, so if you can progress to the final slide.
Absolutely. So, 3 easy ways to get started. We have a free DocDB playground that doesn't require an Azure account or subscription that will allow you to explore the query language. We have a bunch of sample applications out there. I showed you the migration tool. And these are just some recent updates. So we now have support for in and between. We'll have support shortly for order by, for ID-based routing, online index policy updates, and so forth. So in the deck, you'll also find a list of links at the end, just some more resources to get started, a bunch of links to videos, how pricing works, our forum, and then, of course, you can always contact us via Twitter. So thank you very much. I'm happy to stick around for a few more questions. If not, my email address is in the deck. Please feel free to just ping me directly with any other questions. Tommy, do we have time to take a couple questions?
Thank you. Thank you very much, Stefan, for an amazing presentation again. Thank you, everybody, for joining us, and hope to see you again next month on our In-Memory Technologies virtual chapter. If you haven't yet registered, go to imvc.sequelpass.org, and then we'll make sure that you know of every session coming up. So thank you again, and hope to see you next month.